And in our last example, we have two square roots again. It looks very similar to our last one that came out very easily, but this one's going to be much harder. And the issue is that I see some kids, this is the number one mistake I see some students try to square both of these square roots, but you can't just square random things. You're allowed to square both sides of an equation. So we really need to follow our process. Our process, of course, is to first isolate a square root. We have two square roots here. We can isolate either one of them and it will come out just fine. I'm going to choose to isolate this, which means that I want to move this other one to the other side. And the way I move it to the other side is by subtracting square root of x minus 1 on both sides. And so I get square root of x minus 4 is equal to, these are not like terms. And now that I have one of the square roots by itself, that's good enough. Now that I have one square root by itself, I can square both sides. I have to be a little careful. This is a binomial. I need to square the entire side. So here, squaring and square root are inverse operations. So x minus 4 will equal, all right, this is a tricky binomial. We have 3 minus this weird thing. Here are two things. We talked about our trick for squaring binomials earlier. We square the first term, so 3 times 3 is 9. We multiply these two together, which is going to give us negative 3 times square root of x minus 1. And we take that answer and multiply it by 2. So minus 6 square root of x minus 1. That's what happens when we multiply these two together and double it. And then we need to square this last term. We have a negative times a negative, which will be a positive. And a square root squared will cancel out and give us x minus 1. All right, now we need to identify what type of equation we have. And because we still have a square root, this is still a square root equation. And the way we solve a square root equation is by starting by isolating the square root. So I'm going to move all terms to the other side. Negative 9, I'm going to subtract on both sides. X, I'm going to subtract on both sides. And negative 1, I'm going to add 1 on both sides. Notice I can't add 6 here because this 6 is multiplying. It is not a separate term. This is all one term. So x minus x is 0. Negative 4 minus 9 plus 1 is negative 12. And it's equal to negative 6 square root of x minus 1. So I moved the terms to the other side. Now I can isolate the square root by dividing by negative 6. Negative 12 divided by negative 6, and negative divided by a negative is a positive. I now have my square root isolated. And so the second step of our process is to square both sides. 2 squared, 2 times 2 is 4. A square root and a square root are inverse operations, so they cancel out. And now I can add 1 to both sides, and I won't show that, but there it is. X equals 5 is my possible solution. Remember, I need to check my solution to make sure there aren't any extraneous solutions. So I'm going to take 5 and plug it back into my original equation for x. And so the equation will now say square root of 5 minus 4 instead of square root of x minus 4 plus square root of 5 minus 1 equals 3. And I want to see, is this true? I'm going to put a little question mark here. 5 minus 4 is 1. Square root of 1 is 1. 5 minus 1 is 4. The square root of 4 is 2. And 1 plus 2 is equal to 3. So this was not an extraneous solution. X equals 5 is the solution set. 5 is the number that makes the equation true, which I checked. There were no extraneous solutions. Hopefully we feel good about this. We feel comfortable with solving square root radical equations. And you feel comfortable with what an extraneous solution is. It's where you didn't make any mistakes, but it doesn't work when you actually try to plug it in and see it. And you feel comfortable that you need to check your solutions here. If you have any questions, feel free to ask your teacher. I'm sure they would love to hear from you and clarify any confusions you might have. Have a good day.